So what is econometrics? What makes it unique? Well, econometrics is similar to statistics and data science, and there's a great deal of overlap in the tools that these three disciplines use. All three are about using empirics or data to answer questions about the world around us, but they focus on different things. Statistics is most interested in inference. Statisticians develop techniques to infer underlying population characteristics from the characteristics of a limited sample. For example, can we infer what fraction of the population supports a certain candidate based on polls with a certain sample size? Data science, on the other hand, focuses more on prediction. Data scientists may develop models that allow them to forecast the value of one variable using the value of other variables. For example, based on the products you've previously purchased on Amazon, can we predict what products you might also be interested in? Econometrics, then, places a greater emphasis on causality. The concept of causality can be difficult to understand, but econometricians tend to find causation with the motto, "There is no causation without manipulation." This is easier to see with an example. Let's say you notice people with this bumper sticker on their car are more likely to have voted for Trump in the last election, and people with these bumper stickers are much more likely to be Biden supporters. You might then observe lots of different people in lots of different cars to the point where you can predict pretty accurately which candidate a person supported based only on the bumper stickers on their cars. You might already be able to do this. For example, you might peg this person as a Republican and this person as a Democrat. What you've done essentially is build a simple and fairly accurate model for predicting a person's political party based on their car's bumper stickers. This model correctly predicts a person's vote most of the time, and so would be useful, for example, if candidates are trying to figure out who to solicit for donations. But let's say a local political party hears about your research, and how it shows with a high degree of precision that people with certain bumper stickers on their cars are much more likely to vote for certain candidates. The party is thrilled and they develop a plan. The night before the election, under cover of darkness, thousands of campaign workers make their way up and down the streets, slapping bumper stickers on every car they find. By the time they're done, almost every car in the country has bumper stickers corresponding to their candidate. Your model would predict a landslide victory. The campaign workers then watch the results, eagerly awaiting the news of their heroic triumph, and, well, you know what happens next. The party's plan wouldn't change the outcome of the election at all. You can use bumper stickers to predict a person's political affiliation, but bumper stickers don't causally affect a person's choice of candidate. We know this because the campaign workers can't use bumper stickers to manipulate a person's vote, as we saw in the story. There's no causation without manipulation. Another phrase you might be familiar with is correlation is not causation. In this example, bumper stickers are correlated with political affiliation, but they don't cause a person to vote for one candidate over another. Econometrics, more than statistics and data science, is interested in discovering the causal relationships between variables. The economics courses you've taken so far have likely been all about causal relationships between variables. For example, you probably learned that a price ceiling, like rent control, causes a shortage of housing. To test this theory, it's not enough to establish a correlation between rent control and the supply of housing. We want to convince people about causation. Trying to learn about causal relationships in the real world like this is called causal inference, and it's at the center of what we do in this course. The goal of the course is to give you the tools to learn about causal relationships in the real world, and to evaluate the strength of other people's causal claims. We will use a lot of tools that are also used in statistics and data science. We'll learn about statistical inference and about how to use models to forecast data, but we'll be utilizing these tools in the service of making better causal conclusions.